Well, hello and welcome, everyone. My name is Celeste Harrison, and on behalf of National Geographic Education, I'm so happy to see you all today and to welcome you to another Explorer Classroom. National Geographic believes in the power of exploration and the power of wonder to change our world. The very heart of our National Geographic community is, of course, our National Geographic Explorers. Explorers are cutting-edge scientists, amazing researchers, adventurers, filmmakers, photographers, and powerful storytellers. These Explorer Classroom events connect students around the world with our National Geographic Explorers for short lessons and extended Q&As. We're now hosting Explorer Classroom every weekday at 2 p.m. Eastern Time in addition to all of our usual events. So if you'd like, I could see you right back here tomorrow for some more Explorer Classroom. But for today, we're very, very lucky to be connecting with Alex Tait. Alex holds the position of the Geographer for National Geographic. He heads the MAP Policy Committee and determines geopolitical guidance for the National Geographic Society, as well as the development of mapping and GIS resources for the National Geographic Labs. He even gets to head out into the field for cutting-edge research. Alex recently spent time on Mt Everest. That's what he's going to be talking to us today about. But before we get to Mt Everest, I'd like to acknowledge that we're joined on screen by a bunch of students today, and we have hundreds and hundreds and hundreds more of you registered to participate with us. I'm so glad to have so many of you out there, and so glad to have so many different places represented. Our students today represent Arizona, California, the District of Columbia, Florida, Georgia, Hawaii, Idaho, Illinois, Indiana, Kansas, Massachusetts, Maryland, Maine, Minnesota, North Carolina, New Jersey, New Mexico, New York, Texas, Virginia, Washington, Wisconsin, and Wyoming, plus Canada, India, and South Africa. I have a couple special shout outs to give today. Abby, the Clarence family, Emil, Daniel and James, Jeff, Kay, Kelly, the Coons family, Lila, Miss Eager's ninth graders, No, the Philman family, Sam and Will, Samara, the McMillans, the Sings, the Ticos, the Weekend Warriors. Hello to all of you. That was an awful lot of you, but I am sure I missed most of you. So let me know where you're watching from and what your name is over in the chat bar. We'd love to say hi later on. Additionally, we know it's not just students out there, there's also a ton of educators with us. This week on Explorer Classroom, we're taking a moment to show our appreciation for teachers around the globe. Your work has never been more important or more apparent than it is right now. So this Teacher Appreciation Week, we're here to say that we see you. Thank you for all you do for your students, for your fellow educators, and for your communities each and every day. From all of us at National Geographic, thank you so much. And with that little celebration of Teacher Appreciation Week, we're now ready to turn it over to Alex for today's Explorer Classroom lesson.
Thanks, Celeste. And I think I want to hear you name all the capitals of all those states and countries you just reeled off so quickly.
That's a different episode, Alex.
Well, I'm really pleased to be here with everybody, and I'd like to add my thanks during this Teacher Appreciation Week to all the educators out there, and not just the ones that work in the classroom in the schools, but also all those people at home that are filling in and helping educate all the kids out there. So real thumbs up. Thank you for all the work that you're doing. And thank you for being on this Explorer Classroom with me and with National Geographic Society. So I'm going to talk about what I do. I'm the geographer at National Geographic Society, and geography is all about understanding our world and knowing where things are, but not just where, but why they are where they are. And that's all about geography. And my specialty is mapping. So that's taking the information that either others gather in the field or that I gather, and then making it into maps. So it's a process. Mapping is both collecting the data, analyzing it, and then looking at it in maps. So I'm going to share my screen with you now and show you some of what the history of mapping at National Geographic is. And then we're going to take a quick tour of some of the work that I did last spring at Mount Everest. So let's get this going on the screen share. And hopefully you can see in the background there a map of Mount Everest by National Geographic. So as Celeste said, I was able to go into the field and work in Nepal on the south side of Mount Everest. And this is a photograph of me setting up what's called a survey base station so we can get a very accurate location for all the mapping work that we did there. But first, I want to talk a little bit about the history of mapping at National Geographic. I love to say that the first issue of National Geographic magazine back in 1888, over 130 years ago, it didn't have any pictures at all, no photographs, which National Geographic is really known for. But that first issue had 4 maps. So maps are always important for communicating, for gathering information and showing it to people. And the very first cartographer or map maker for National Geographic Society, he also got to work in the field. This is a photo of him in Peru, and he worked with an expedition that National Geographic sponsored that mapped in very great detail the Inca city of Machu Picchu. So I love that I'm following in the footsteps of very great geographers and cartographers at National Geographic Society. And all that work continues today in National Geographic magazine, on the TV channels, and other things that National Geographic does. This is an example of a beautiful map that was done by some colleagues of mine about 2 years ago about bird migration. And it combines detailed data with beautiful illustrations and a wonderful map. This is one of the birds they highlighted. It's one of my favorites. You see it out west in the United States, the western tanager. So of course, National Geographic is always combining beautiful photography, videography, maps, and beautiful writing to tell stories about our world. And one of my specialties is actually making maps. And I was very fortunate to be able to make a map of Mount Washington, the highest peak in the state of New Hampshire in the eastern United States, for the magazine. So this is a map that I actually made about 10 years ago. So let's move on to Mount Washington, which National Geographic has a long history of supporting work there. A very famous cartographer named Brad Washburn created the most detailed map up to that time of Mount Everest. This was in 1988 and was published by National Geographic. And you can see that they're working with hand tools. It's an airbrush to paint the map. And it's one of the most beautiful pieces of hand-rendered cartography that we've ever seen. And let me show you a little bit of a detail of that map. You can see it combines rock hatching and shaded relief, and it depicts the glaciers and the snow cover in this area on the border between Nepal and China. So I was very fortunate last year to be part of a very big expedition, a science expedition to Mount Everest to take a look at what things had changed and how the mountain environment was changing. In particular, I was looking at how the glaciers changed in this time of changing climate in our world. We had a very big team. We had over 30 scientists and a very large support crew that was helping us. We had scientists from Nepal, from India, from all over Europe and North America. And we were studying biology, geology, glaciology, which is studying the glaciers, and meteorology, studying the weather on Mount Everest. And that's a picture of our crew in the capital of the Khumbu region of Nepal called Namche. So I led the mapping team, and this is my colleague, Chris Milburn. He's working with a drone flying at Everest Base Camp at about 17,500 feet in elevation, very thin air, which was our base. And he's mapping base camp with the drone, flying it all over and taking pictures that we merge into a map. We also had a team that worked by helicopter, and we were mounting what's called a light ranging and detecting device, a LiDAR device, to the helicopter to do very detailed mapping of the glaciers. So this is a quick map. I love maps, always like to show maps when I'm talking about the work I do. This shows the entire extent of the Khumbu Glacier Valley, and that's the area that we mapped. And when you get LiDAR data back, it's a lot of little points that indicate the position of the terrain in 3 dimensions. And it doesn't look like a glacier right now, but we can convert that into an image that shows the details of all the crevasses of this glacier, the highest glacier in the world. So I want to switch to a quick show and tell. So I'm going to stop sharing my screen and show you some of the things that we brought to Mount Everest to work on the mapping. Does that work, Celeste? All right. So of course we needed to be able to navigate a high and icy place. And so we needed to bring ropes to work in the high mountain places safely. And so we were anchored when we were in dangerous positions. We also had to use a special ice axe ski pole combination to be able to work on the very icy surfaces, and we had crampons on our boots. Now, for the mapping work, I showed you what my colleague Chris was working with. This is the actual drone that we flew at Mount Everest. I just happened to be storing it at my house when we were limited to working from home for the last 3-4 weeks. So this is the actual drone. Let's see if we can get the sound effect. All right, that's the drone getting in position and firing up to launch. So we flew this drone for about 3 weeks. So we flew the drone for about 3 weeks at base camp. We took over 32,000 photos to make a map of Everest Base Camp. So that's a lot of the work that I've been doing over the last year. And now I've come back to the office. Of course, it was wonderful to be on the mountain and in that beautiful environment. But now it's a lot of work of processing the data, making maps, and writing papers to show what's going on in the high mountain environment, because it is changing and the glaciers are receding and getting smaller. So that gives you a flavor of the work that I get to do. It's a combination of working in the office at National Geographic and then getting out into the field. All right, Celeste, I'm ready for questions.
Oh, amazing. I bet we've got some great ones out there. I just absolutely love listening to you talk about maps and hearing everything about that Everest expedition. It's so cool. Every time I learn something new, I'm surprised and impressed. We'd love to know what you folks at home found impressive about today. Maybe you do a follow-up activity from the Family Guide, draw a picture, write a story, make a comic strip, produce a video, whatever it is, we would love to see it. You can send it to us by tagging @NatGeoEducation on Twitter and using #ExplorerClassroom. That way Alex can get a chance to see all of your cool maps too. But now it's question time. So if you're watching online, keep sending those questions in the chat bar. We record all of them as they come in, so you only need to send each question one time. And if you're up on screen with me, get ready with a nice loud voice. I'll let you know when it's your turn. Our first question comes to us from Molly K on YouTube. She's wondering, in the geographer's opinion, what is the most interesting mountain and what is the most interesting map?
Wow, those are two great questions. As you might imagine from some of the samples I showed, I love mountains. I'm a mountain climber. I love to go climb mountains in the United States, in my backyard in Maryland as well, in the smaller mountains we have here in the Appalachian Mountains. And then of course, it was a treat for me to be able to go to the Himalaya to be on, I didn't climb to the top, but to be on the biggest mountain in the world. But I've got to say that one of my very favorite mountains is in New York State, because it was one of the first mountains that I ever climbed. And it's called Mount Algonquin. It's in the Adirondack Mountains of New York. And I was so proud as a young kid of about 7 years old to climb up that mountain. So that's still one of my very favorite mountains. Now, I love maps and I love mountain maps, but one of my very favorite maps is actually of a canyon, not a mountain. National Geographic published a map of the Grand Canyon that was done by one of my heroes, Bradford Washburn, who also worked on the Everest map that I showed you. And his map of the Grand Canyon is an absolute masterpiece of cartography. And it's my very favorite map.
Brilliant. Well, Zoe on YouTube is just saying, "Woo, Mount Algonquin!" So you've got some fans out there. Let's take a question from an on-screen group. Let's go to the Nagels. All right. Give me 1 second with your microphone. All right, you're unmuted. Go for it. What's your question?
Um, is there like when you climb when you're working to do the expeditions, how do you have to did you climb
How did you train?
how did you train? Did you do like altitude training? Were you had to do like some type of altitude training, right?
Yeah, so we did quite a bit of training. So I had to do physical conditioning here in Maryland, where I live, which meant doing a lot of hikes in the Appalachian Mountains nearby. So I could put on a 30 or 40-pound backpack and hike up hills as much as I could. That was really good training for going to Nepal. When you're living near sea level like I do, there's no way to simulate altitude. And so what you do when you go to Nepal, you fly into Kathmandu, which is at about 4,000 feet. You're there for 4 or 5 days, and then you fly from there to a little village in the Khumbu region, about 30 miles from Mount Everest, called Lukla at about 10,000 feet. And then you very slowly, over about 9 days, you hike 30 miles to Mount Everest. So you'll hike about 8 miles and then spend 2 nights to let your body adjust. So there's no way to really simulate altitude effectively without going there and being very careful about acclimatizing. But we also were very smart. Our logistics people were very smart. They said, you need to go in January before your big expedition, go to Nepal for a 3-week trip. The second trip was 2 months, 3-week trip to get used to being there. And we did the same process, and we went all the way up to base camp and back in 3 weeks in January. So when we did our science work, it was the second time we went.
Really smart solutions. We've got so many people, too many to list in the chat bar, who are wondering some of the basic geography about Mount Everest. Where is it? How high is it? How much area does it cover? That kind of stuff.
Those are great questions, and I was remiss in not putting a locator map to help people out. I spent so much time there and I've made so many maps of it. I know exactly where it is. But if you can imagine, it is in Asia. It's the highest mountain in the world. And of course, that means it's the highest mountain in Asia. And it is on the border between Nepal and China. So if you imagine China to the north, Nepal and India to the south, there's this long mountain range that divides Nepal and India from China, and that's the Himalaya Mountains. And Mount Everest is located just east of center of this long, skinny range of mountains, the highest mountains in the world. So there are 14 peaks over 8,000 meters. They're well known in the climbing world. And 8 of those are in the Mount Everest region in Nepal.
Brilliant. And Bryson online is wondering how you go from mountain to map. What are the steps in between seeing the mountain and getting it down on paper?
Another great question. And I showed you a little bit of that process. So we used drones and helicopters to collect data. Some of the data was simply photographs straight down from the helicopter or from the drone. Some of it was LiDAR data, which is sending a beam of light and measuring how far it went. We take that data and we combine all the photographs into one big photograph, and then we can derive the map information from those photographs that have been referenced so that they're all in the right location. We then either manually, or you can do it with some automated process, we draw out where the glaciers are, where the rocks are, where the mountain peaks are, where the trails are, these are. And so that information that we got from drawing, either manually in a computer using a mouse, or you can get the computer to use artificial intelligence to derive that information automatically. And then that gets put into a map that you can show to people.
Super cool. Thank you for that. Let's go to the Ruckers for our next question. Your microphone's on.
How did you get your job and what did you do to get it?
That's a great question. I have a fun job. I get to do a lot of interesting stuff. I studied geography. So when I was in college as an undergraduate, I studied geography. And I actually studied biogeography, which is the location of plants and animals. And I realized I loved making maps of all the things that I was studying. So I then studied in graduate school, I studied map making and mapping and how you create maps, how they've been made in the past. So I have a background in mapping and geography. And my very first job out of college was as an intern at National Geographic Society. So I knew about the place because I was an intern there 30 years ago. And then I came back after 25 years because there was this position called the Geographer, and it sounded like a lot of fun. So you need to study what you're interested in, and then things sort of happen as you pursue your interest.
Love that. We've got Nat R, who's wondering what your favorite tool is, and Elijah, who made it a little bit more specific. What was your favorite tool on the mountain?
Wow. So I got to say it was a lot of fun to fly the drone, but one of the things that I really love to be able to do is to move around on the mountain effectively. And you need to have the ice axe and the crampons. And if you've never put crampons on your feet, maybe some of you have, or you know somebody who has, you put crampons on your feet and you can walk up ice, which is an amazing thing without slipping. So I think crampons are amazing. And they have 2 points out the front of each crampon on your boot, so you can actually climb up vertical ice. And that's my favorite tool, is those crampons that let you climb vertical ice.
Awesome. Well, let's go to Annika and Vidya. Working on your microphone now. All right, what's your question?
I have like 2 or more questions, so like I have 2 or more questions. One of them is, are there any animals on the mountains?
That's a great question. And I worked closely with Tracy, who was our biology expert, and she and the other 2 biology scientists, they were looking at what plants and animals are at very high altitude in the Himalaya. And we just got out of a science conversation talking about several different things that they've been looking at. So they're looking at things like juniper bushes. How high do the juniper bushes grow in the Khumbu? We're talking about plants that are growing over 5,000 meters. So that's over about 16 or 17,000 feet up on a mountainside. These are very hardy plants. But one of the most fascinating things that she's been looking at is not just the big animals, and there are things like snow leopards that are in this area in Nepal. And I was very fortunate to see footprints of a snow leopard. Very rare to ever see one, but I saw footprints of a snow leopard. But she was looking at ponds and the water in the ponds and looking at all the microorganisms that grow in each of the ponds near this area in Mount Everest. And she was looking at the differences. One valley could be very different than the next valley and what microorganisms were in the water. And the microorganisms will reveal how healthy the ecosystem is, and they can look for DNA in the water to see what animals have been around.
Very neat. We've got Susan online, who's very impressed by that map of the surrounding glacier and is wondering if there's any equipment that can tell what the rock profile is like underneath ice.
That's a good question. I actually made sure that I had the map handy. You saw it on screen, but I wanted to unfold the map for you all so that you understand just how valuable a paper map is. We brought paper maps to the mountain as well as our computer and our computer maps. Paper maps in extreme environments are still incredibly important in case your battery runs out. So I've always liked to say that paper maps aren't going away just because we have incredible mapping resources on the computer. But the question was about the rocks under the glacier. And one of the geologists that I was working with on the team, he's looking at the very recently exposed rock, because as the glaciers recede, they expose bedrock. And he looks at how long the rock has been exposed in different locations away from the glacier so he can get a measure of how quickly the glacier has changed. But if you want to peer down through the ice, you have to do something that we didn't have time or resources to do in this particular expedition, but you can use radar to send a pulse through the ice to see how deep it is. And that's what scientists, some of the scientists we worked with, that's what they've done in Antarctica to see how deep that Antarctic ice sheet is. So maybe that'll be the next expedition.
Brilliant. Always good to have goals. We've got Molly on YouTube who's wondering if there's internet on Mount Everest.
There is, and that's fairly recent. I think 10 years ago, the answer would be no. But there was a very entrepreneurial team of Nepalis who set up Everest internet. And they had a little tent on the highest point in base camp where they had a Wi-Fi antenna and you could connect to internet. It wasn't always really strong, but you could get internet at Everest Base Camp. They did very well during that season because you'd have to buy a little card with 5 megabytes on it or 100 megabytes, and each time you had to pay to get more internet access. So a very entrepreneurial team that set that up.
I was not expecting that answer. That's awesome. Let's go to Sarah for our next question. Let's see, Sarah, your microphone's on. Go for it.
How do you know, like, what months are safe to go? Are there certain months that are safer to go, like on the mountain than others?
Yes, so it's very seasonal as far as when it's safe to be on Mount Everest. Almost all the climbers that have ever climbed Mount Everest climb it in about a 3-week window in May. So from May 6th or 7th until May 28th, that is what's called the climbing window. And that's when it's safe to be very high on the mountain. The rock and ice, the ice in particular, is still pretty well frozen from the long winter. And you don't have the monsoon rains and bad weather that come in at the beginning of June. So that's when most people climb it. But a few exceptional climbers have actually climbed it in the winter. Very, very few, but people do climb it then. So we timed our expedition to be there at the best climbing window because our meteorologists were going all the way as high as they could go to set up a weather station. And our glaciologist was going to drill what's called an ice core at the South Col. And ideally, he would have been able to get all the way to the summit to do that. But our teams got to 8,400 meters, which is about 27,000 feet. But not all the way to the top. And so we set up the highest weather station in the world, and we took the highest ice core ever taken anywhere on a glacier.
Amazing. Username Yo Was Up is asking what the funniest thing that happened on this expedition was.
Well, you know what? We had one of the scientists had a student with them, and that student was set to graduate in May from the University of Maine, but she wasn't at graduation. So we had a special graduation for her at Everest Base Camp, and that was a lot of fun.
What a cool, very special graduation. All right, we've got Mrs. Midget's 5th grade class up here with us. Mrs. Midget, is there a student you'd like to call on?
Let's see here. See if somebody has a hand up. Anybody have their hand up? Emmanuel.
Brilliant. You can turn your microphone on and ask your question.
What made you want to study Mount Everest?
Well, there were several reasons that I wanted to go on this expedition. One is that it gave me a chance to go into the high mountains, the highest mountains in the world, which I had never been to before this expedition. So that was one of my personal goals. But from a professional standpoint and from a National Geographic standpoint, we wanted to go someplace that people know about and can learn about how climate change is affecting an environment that's very, very sensitive to changes in weather and climate. And so we wanted to go take a look at what has been happening with the glaciers. The glaciers have been mapped for about 70 years. And so we can look at the history of mapping of the glaciers at Mount Everest. And so that was one of the reasons we wanted to go there. It's had so much attention because of the climbing expeditions over the last century that there's actually a very good historical record of what the environment has been like at Mount Everest. Plus, I think just about everybody knows about it.
Pretty cool. We've got a bunch of people wondering if you used oxygen while you were up there and how cold you got where you were on the mountain.
So I personally did not need to use oxygen. I stayed at base camp and about 1,000 meters above base camp. So I never got higher than about 6,000 meters, almost 20,000 feet. And unless you're not doing well, then you don't need oxygen that high up. But our teammates that were going all the way to 8,000 and then 8,400 meters, they did use oxygen. You can't work effectively at that altitude without oxygen. There's some very exceptional climbers that do climb Mount Everest without oxygen, but it's very rare and they have to be very fit and accomplished climbers. So as far as how cold it was actually colder during our trip in January, our training trip. It was much colder because that was January in the high mountains. By April and May, it was definitely warmer. So I think it was about minus 10 degrees Fahrenheit was the coldest I was in. So I've actually been climbing in colder weather in the United States in winter. I was up in Maine climbing on Mount Katahdin, which is the highest mountain in Maine, in February when it was minus 30. So I was actually colder there, but it was cold in January in Nepal. We also didn't go to the summit. At the summit, it's minus 40 or minus 50.
Oh, that was going to be the next question. You stole it from me. Good job. Brilliant. In that case, we've got a ton of people wondering if you've fallen into a ravine, just all of the different possible dangers, those ice falls, which are so treacherous. Can you maybe go through some of the safety precautions your team took?
Sure. I stayed safe at Mount Everest, and our logistics team and our director of expeditions were very careful to make sure that we had safety equipment whenever we were out on the glaciers. That rope connects you to other people and to anchors that are set up in the snow and the ice and the rock so that if you fall, the rope will catch you. So we had no accidents. Everybody was safe on the mountain. So that part of the expedition was very successful. And that was important to us, that we didn't want to put any of our scientists or our support team, and we had a very important support team of climbers from the Khumbu region of Nepal. These Sherpa climbers were very important for the success of our work, and we couldn't have done it without them. And I'd just like to give a shout out to all those teammates that helped us with our work. And of course, this was National Geographic and Rolex who put all the resources behind us to let us be successful in this work.
Brilliant. We've got Aisha who has a question. I'm going to turn your microphone on. Oh, it is fighting me back. Aisha, can you turn your own microphone on for me? Perfect. Go for it.
My question was, so what was the highest mountain and how cold was it?
All right, well, the highest mountain that we were working at was Mount Everest, and there were climbers that summited that mountain. And I actually know, as a geographer, you tend to have some numbers stick in your head. So I know exactly how high Mount Everest is. It's 8,850 meters by National Geographic's measurement, or 8,848 meters by some other measurements. And it's interesting that there isn't agreement on the exact precise height of Mount Everest. It's actually very challenging to get that height, very precise fashion related to sea level. And that's a whole nother story, but so that's the biggest mountain there. I was able to climb up to part of a mountain nearby at 6,000 meters. And so that was the highest that I got to. So 6,000 meters is about just under 20,000 feet. So that's higher than all the mountains in the United States except for Denali in Alaska.
Cool. We've got a lot of questions about food on Everest and about sleeping arrangements on Everest. Can you tell us a little more about life up there?
Sure. So during our hike from the village we flew into up to Mount Everest, as I said, that's about 30 miles. And we stayed in what are called tea houses or mountain lodges on the way up to base camp. And so that was very, very nice sleeping arrangements in beds and bunks. But at base camp, we were all in tents. Base camp has about 1,000 people during the peak climbing season, and that's all the climbers and the support crew, the guides and the cooks and the people that are called porters who are bringing equipment and provisions up to base camp. So there's about 1,000 people living in tents. And so you're in a sleeping bag on a ground pad in a tent. And I was there for 6 weeks sleeping in a tent. Longest time I've ever been in a tent. And we had a wonderful cooking crew that made all our meals for us. So I am so thankful. I've done a lot of backcountry camping on my own where I have to cook my own meals. So I was really thankful. And they gave us a combination of Western style food and Nepali food. One of my favorite Nepali dishes is called dal bhat. And it's a plate full of lentils and chicken and vegetables and a pile of rice. And it's a wonderful Nepali meal. You get it up high in the mountains and it's very filling and very satisfying.
Awesome. Let's go to Adele. You've got a question. Go ahead and turn your microphone on and ask it.
How hard was it to live up there? Did you?
So it is very tiring just living, let alone doing any work, just living at 17,500 feet. Your body gets very tired very fast. And there's about, I think the number is half the amount of oxygen that you can get out of the air at that altitude compared to sea level. And so your body gets very tired and it gets run down. And I actually got sick when I was up there with an intestinal bug. And I actually had to go down to lower elevation for a little while and then come back up. So if you get sick and you don't get better, you actually have to descend and go down to one of the villages, and then you can come back up when you're well. So quite a few of our teammates had the same issue. And so I did it once and for about 5 days and then had to come back up. So yes, it's very taxing to work. And you'll start hiking up a hill that in your backyard, you would just run right up it. And after 3 steps, you're huffing and puffing. There's not much oxygen there.
A couple fun questions came to us from Catherine in the YouTube chat bar. Catherine is wondering if you, as the geographer, have ever found something that was thought to be lost, and if the geographer ever gets lost.
Well, you can ask my family about getting lost. I always think I know where I'm going, and most of the time I do, but boy, when I get lost, I really get lost because I get turned around. So yes, I do get lost, and I never trust the mapping app, either Google Maps or whatever map. I don't trust it. I think I know better way to go when we're driving around. So that's always amusing when I get it wrong. As far as finding anything that's never been seen, well, by the time I was mapping, creating maps and working on things, so there are parts of the Khumbu Glacier that have never had any person walk on them that we have super detailed maps and photographs of from the work we did. So I can look at the incredible details of all the rocks and the ice in parts of this glacial valley where nobody has ever been. So that's sort of a new discovery.
Brilliant. Well, the Ruckers look like they have another question. All right, what is it? Go for it.
What is the most dangerous situation you or your crew have been in?
Well, as I said, it was a very safe expedition. So I'd say that probably, as far as me personally working with National Geographic, I did get to go to South Africa for work. And I was driving around one of the amazing protected areas in South Africa. And we were at night, just as the sun was going down, we were driving back to our camp, and there was a bull elephant in the middle of the road that was tearing apart a tree. And he didn't really care about us. He cared about tearing apart this tree, but that's probably when I was the most nervous, is like, we're just in a car. This elephant could destroy the car. But he was showing what he could do tearing apart a tree. So maybe that would probably be the most nervous I've been. I know that the elephant probably wouldn't have done anything to us, but it was an amazing sight.
Is there anything that makes you nervous when you're just mapping at your desk on paper when you're not out on expedition?
Well, most of the work I do on the computer so that I can hit Command Z and undo my mistakes. So I love that. But every now and then I'll be doing something truly by hand with pen and ink. I'll be doing a field sketch. And sometimes I wish I knew. And I'd say the most I've been, some of them gotten published in places like National Geographic magazine, or I did work at the Washington Post, which is a newspaper, and I'm always worried about mislabeling a place. And when I was doing work for the Washington Post, I was making a map of Germany, and I labeled one of the states in Germany, and I was like, was that the right state? And it bugged me all night when I was trying to get to sleep. I was like, did I get it right? And the next day, sure enough, somebody called up and said, you put the wrong name on the state in Germany. So I made a mistake that got published in the Washington Post. That's the biggest nervous thing I have with map making, is making an error like that.
Makes us great for our teachers with their red pens, right? To help us out before it gets out.
But the thing is, it happens, and you just make it right the next time.
Love it. We've got Samara, who was commenting on that really beautiful kind of rainbow relief map.
Yeah.
Explain a little bit more about LiDAR and how that works.
Sure. So that rainbow color was showing lower elevation points and higher elevation points. And every one of those little dots on that map was showing a location in 3 dimensions that the LiDAR had measured. And what LiDAR does is, there's a device on the helicopter, is the way we did it. So it's mounted to the helicopter. It sends out a pulse of light, travels very, very fast, of course, hits an object, and it comes back to the device. And the device measures how long that took, and it can translate that into how far away that point is. So every point has an X and a Y and a Z location in 3 dimensions. And you get millions and millions of those points, and it describes the surface of what the light saw, so that you're getting a terrain, what we call a terrain model, that shows exactly where the surface of the glacier and the rock is. So every one of those points, and that image only shows a very small sampling of it. There's hundreds of millions of LiDAR points that we collected at Mount Everest.
Super cool. Alex, we've got a small contingent of people just asking us over and over and over again, would you rate on a scale of 1 to 10 how fun your job is, and on a scale of 1 to 10 how cool the Everest expedition was?
Well, the Everest expedition's a 10. That's one of the best things I've ever gotten to do. And I've gotten to go to some really interesting places. So I'd rate the Everest expedition a 10. And my job is great. I love my job. So, I'd give it a 9. Every job has some things you don't like to do. Get back to the office and you're like, oh God, I got to do this and that and the other thing. So, it's a job sometimes, but it's a lot of fun a lot of the time.
Love that. And Alex, is there a teacher or a role model in your life that you'd like to give a shout out to for Teacher Appreciation Week?
So this is a teacher that I met at summer camp. So she was also a summer camp counselor. And I'd give a shout out. It'll be a shout out to her family and to all the people who knew her. She's not with us anymore. But when I was a young camper of about 10 or so, she was a nature counselor, and she was a teacher during the school year. And her name was Mildred Brooks. And she brought us out into the wild to live off the land. And so we learned how to eat nettles and other things that were in the woods and how to survive in the woods. And I always thought that was an amazing thing. And so she taught me a lot about how to look at the world, understand it. And she, in many ways, was a geographer, though she probably wouldn't have called herself that. one of the distinct memories I have with her is there was a fox that was killed on the road near the camp. And so she saw that as a teaching opportunity. We took the fox's body, we buried it, and then each year we'd see what was there when we unearthed it. It was very, very cool. So it was several years that we looked at that one spot. And so the flesh would rot away and you'd see that. It's a little macabre, but it was a great teaching moment.
Gross. I love it. For our last question, Alex, do you have any advice for all the young explorers out there with us today?
So my advice would be to start looking at the world out there and think about, why are things located where they are? So this can be at the level of your neighborhood. Why is the park where it is? Did somebody put it there on purpose to serve a lot of people? Where are the streams in your neighborhood? Where are the hills? How does that relate to something else like the geology? What rocks are around? So just start taking a look around your neighborhood and think about both the physical environment. Where are there trees? Where are there not trees? Maybe there's more trees on the shaded side because they don't get dried out as much. Out west, you see a lot of hillsides with in the shade have a lot of trees, and the other hillside in the sun, no trees at all. So I call that looking at the world as a geographer, and think about where things are and maybe why they are there. And of course, I would encourage everybody to make a map of your neighborhood, where you go every day. Show your friends, your family where you walk. I've been doing a lot of walking lately.
Love it. What cool advice. Thank you, Alex. Well, for everyone out there watching, you can check out Explorer Classroom and many, many more free educational resources at natgeoed.org. I hope to see you at some of our upcoming events. If you stick around a little longer, at 3:30 Eastern time, we've got an event for high school students called Behind the Headlines, where you get a chance to meet Thomas Aosu. Going to be great. And then tomorrow at 1 p.m. Eastern, Dalal Hana is going to open up a bunch of beehives for us. That should be fun. And at 2 p.m. Eastern tomorrow, we have a lesson with Lucy Hawks, who's going to teach us all about how she tracks animals. She's tracked all kinds of stuff. It's really neat. She's got a bunch of cool gear to show us. I'm pretty excited. But for now, let's say thank you and goodbye to Alex. I'm going to turn on everybody's microphone. Let's get nice and loud and say thank you and goodbye. Ready?
I have a question.
Bye.
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 Bye. Thank you.